All right. So let's just make sure we understand what this value is, right? This is the fraction of the sun's total power that will hit the Earth.
Yeah.
So it is not an amount of power. To get the amount of power, we should have to multiply that by the power of the sun, which it's up here, 3.90 times 10 to the 26th watts.
How do we know that?
How do we know that?
Yeah.
I don't know. What? It doesn't seem weird to me that we would know that.
I don't know, just like, how would you find that out?
We had people go in the sun.
Well, if we know how
But it's all
bright
fusion.
it is,
And
right? That's the power it's giving off, is the light. So,
then, okay.
I mean, if we can see how bright the light bulb is and know what its power is, I don't see why that's so
We're
weird.
running out. Like,
All right, so I'm now getting 1.77 times 10 to the 17th watts.
Yeah.
So 1.77 times 10 to the 17th joules per second, which just strikes me as an immense amount of power. And it actually makes me wonder if something's wrong. No, I think we're good. I think we're good. But that is hitting the Earth, right? The circle of the Earth. But we don't really care about the circle of the Earth. We probably care about, what's the power that's hitting like this 1 square meter of Earth. All right? So watts per square meter is actually the value that we would care about. And if we divided this by the total surface area of the sphere that is the Earth, then we would get that. And I actually want to do that because I want to make sure this is right, and that's the only way that I can check that. But we should be able to do that with the data we already know. Right? The surface area of the Earth's sphere, right, would be 4 pi r squared, I think. Right? Surface area of the sphere.
Would it only be half that because it's only hitting half the Earth over time?
Well, no, but the Earth's spinning. So on average, right, a meter squared of the Earth would get this divided by the surface area of the sphere. Is this right? 4 pi r squared is the surface area of the sphere?
Yeah, that's what we did.
Alright, so I just want to divide this amount by 4 pi times 6.4 times 10 to the 6th squared. And I hope we get something like about 300. We do? Alright, 300 what?
44.
Great. 344 watts per meter squared. Alright. So that is, on average, like over a 24-hour period, that is the amount of radiant power that strikes the Earth. Okay.
Is that assuming there's like no clouds or anything blocking it?
Right.
And
So
that
if that
it's
hits the
actually
cloud and not right, so that assumes a lot. That assumes no clouds. It assumes
No time.
No satellite.
there are latitudinal variations in that we'll come back and talk about next time. There are seasonal variations, right? So we're not getting today to so anyway, that's what we have to look forward to next time. We did, Jamie. We did, Matt. We did do enough that I want you to try the second problem in the homework packet as well. All right? So we definitely have some more power to do next time, but I'm happy with where we got to today.
This is perpendicular to our point.